Hello my dear students. In the last video we were discussing about the electric potential and potential difference. Now let us go for the new concept from your syllabus, that is what? The expression for electric potential at a point due to an isolated point charge. This derivation can be derived by making some modification, and that modification is, see, consider a point charge Q is placed at a point O and another unit positive charge 1 coulomb is placed at a point P such that the distance of separation between Q and plus 1 coulomb is OP is equal to X. These two charges are like charges, therefore there is a particular force of repulsion between them. That force of repulsion according to Coulomb force expression you can write, it is E is equal to 1 divided by 4 pi epsilon naught Q divided by X square. This content what it says, the electrostatic force of repulsion between Q and plus 1 coulomb is F is equal to 1 upon 4 pi epsilon naught Q divided by X square. But the thing is, plus 1 coulomb what it says, it is a test charge. Test charge means what? It tests the electric field. Test charge, it is an infinitesimal smallest charge used to evaluate the strength of electric field, used to evaluate the strength of electrostatic force. Therefore, test charge is 1 coulomb and Q is what? Source charge, which produces the amount of electric field around it. Therefore, we are going to, by the help of this equation, we can easily understand that the force experienced by 1 coulomb of charge due to Q is completely along OP. Therefore, F is equal to 1 by 4 pi epsilon naught Q mod of Q multiplied by mod of 1 divided by square of separation between them is what? It is X square. Mod of Q and multiplied by mod of 1 becomes what? It is Q itself. The direction is along OP because the amount of force experienced by 1 coulomb of charge due to plus Q, this is along OP. And the next one, the work done in displacing unit positive charge from P point to A point through a small distance dx in an electric field due to Q is given by, that is, work done is equal to scalar product of force and displacement. Scalar product of force vector and displacement vector. And the next one, this content we can write, it is mod of force vector, mod of displacement vector, cosine of angle between them. See, here mod of force vector becomes force and the displacement vector becomes the displacement itself, cosine of angle between them. See, here we are moving the given 1 coulomb of charge from P point to A point. It means the displacement is completely opposite to the direction of electrostatic force, the direction of electrostatic field. Therefore, the amount of, that is, work done we can write, it is dW is equal to minus of F dx. In other words, the displacement is opposite to the direction of electrostatic force. They are completely anti-parallel to one another. Angle of inclination between force vector and displacement vector is found to be, it is 180. Cos of 180 reduces to minus 1. On substituting this value into the above equation looks like dW is equal to minus of F dx. And the next one, in the place of F we have to substitute this equation, and then we can write dW is equal to minus of 1 upon 4 pi epsilon naught Q divided by X square multiplied by dx. And the next one more content what we have, negative sign what we have taken in the above equation, that indicates the displacement is opposite to the direction of electrostatic force. And the next one, the total work done in displacing unit positive charge from infinity to the point in an electric field. In other words, the total work done in displacing 1 coulomb of charge or unit positive charge from infinity to the point A in an electric field, that is x is equal to infinity to x equal to r. X is equal to infinity to what? X is equal to r. Then total work done can be calculated by integrating above equation between the limits x equal to infinity to x equal to r. Then above equation reduces to integration of dw. Here integration of, that is dw is what? Minus of 1 upon 4 pi epsilon naught Q divided by X square multiplied by dx between the limits x equal to infinity to x equal to r. And the next one more thing is what? Here variable is what? With respect to dx is there, x is variable, remaining factors are constant, keep outside from the integration. Therefore, above equation we can write minus of Q divided by 4 pi epsilon naught integration of 1 upon x square dx between the limits x equal to infinity to x is equal to 1. 1 upon x square dx. Here this equation it completely looks like integration of x to the power of n into dx is what? X to the power of n plus 1 divided by n plus 1. And the next one, on simplifying, only 1 upon x square dx is completely reduces to what? It is minus of 1 by x. As we know that, see, that is by the help of this equation, integration of x to the power of n multiplied by dx is equal to what? X to the power of n plus 1 divided by n plus 1. X to the power of n plus 1 divided by what? It is n plus 1. See, by the help of it here, 1 upon x square dx is there. On simplifying directly we can write it is x to the power of minus 2 into dx is equal to x to the power of minus 2 plus 1 divided by minus 2 plus 1. This reduces to x to the power of minus 1 divided by minus 1. This is equal to minus of 1 by x. Therefore, directly I have taken integration of 1 upon x square dx is equal to minus of 1 by x. Therefore, integration of 1 upon x square dx is what? Minus of 1 by x. Upper limit, lower limit, keep as it is. And the next one, minus becomes what? Positive. Therefore, q divided by 4 by epsilon naught multiplied by in the square bracket 1 by x. Upper limit, lower limit, keep as it is. In the place of x, we have to substitute the first upper limit minus. We have to substitute in the place of x as infinity. And the next one, on simplifying, w is equal to q by 4 by epsilon naught 1 upon r minus of 1 divided by infinity. 1 by infinity reduces to 0. And the next one, w is equal to 1 upon 4 by epsilon naught q divided by r. By the definition of electric potential, what it says? The amount of work done in bringing unit positive charge from infinity to the point in an electric field without acceleration is known as electric potential at that point. Here we are bringing unit positive charge, therefore a potential and work done both are numerically equal to each other. Therefore, W is equal to V. In the place of W, whatever we have in our equation, that can be replaced by V. Therefore, equation it looks like V is equal to 1 upon 4 pi epsilon naught Q divided by R. This is what the expression for electric potential at any point due to an isolated point charge. The parameters involving in this equation, they say the usual meaning. 1 upon 4 pi epsilon naught in the sense what? 1 coulomb charge and Q, which are placed in vacuum or free space or air medium. That medium permittivity is denoted by epsilon naught. Basically, epsilon naught value is found to be 8.854 into 10 raised to minus 12 farad per meter. Q in the sense what? The charge which produces the electric field. Simply, that charge is what? It is a source charge. In this diagram, the source charge is positive. That is why we have taken plus Q. And the next one, distance at which the given 1 coulomb charge is brought in an electric field. That distance from the given charge, from the source charge, that distance is what here? It is R. It means we have brought the unit positive charge from infinity to the point A. Point A, which is at the distance R from the plus Q charge. Therefore, the distance, the distance is what we can write, it is R. V is equal to 1 upon 4 pi epsilon Q divided by R. This is what? The expression for electric potential at a point due to an isolated point charge. And the next one, instead of a positive source charge, if source charge is negative, then amount of electric potential at a point A, amount of electric potential at a point A due to negative source charge is given by, that is V is equal to 1 upon 4 pi epsilon naught minus Q divided by R. Minus Q denotes negative source charge, R means the distance at which we are calculating the electric potential due to minus Q charge, and one more 1 by 4 pi epsilon is a constant, and V is what? Potential at a distance R due to negative source charge. And the next one, this is what the concept of the whole, that is electric potential at a point due to an isolated point charge. One more time, I repeat the same concept. See, electric potential at any point due to an isolated point charge. This expression can be derived by help of certain modifications. Let us take a point charge Q placed at the point O, which produces the amount of electric field R around it. Let 1 coulomb of charge be placed at a point P at a distance x from the source charge Q as shown in a given figure. Let x be the separation between plus Q charge and plus 1 coulomb of charge. These two charges, with the help of diagram, these two charges are like charges. Therefore, the coulomb force between them is given by F is equal to 1 upon 4 pi epsilon naught Q divided by x square. In other words, the force experienced by unit positive charge due to source charge Q is given by F is equal to 1 by 4 pi epsilon naught Q divided by x square. This direction is along OP. And the next one, let dW be the work done in moving 1 coulomb of charge from P point to A point. Then work done is given by dW is equal to scalar product of force vector and displacement vector. Scalar product of force and displacement on simplifying F dx cos of 180 degree. Here, angle of inclination between force and and displacement is totally one degree because we are displacing the unit positive charge from P point to A point. But the direction of electrostatic forces is completely along OP. Work done is completely moving one coulomb of charge from P point to A point. It means displacement P to A, but the direction of electric force is O to P. Both are opposite to one another. Therefore, angular inclination between force vector and displacement vector is, it is 180 degree. Cos of 180 reduces to -1. On substituting this value into the above equation reduces to this form. In the place of F, we have to substitute this equation. On simplifying, the work done in moving unit positive charge from P point to A point to a small distance dx is given by minus of 1 upon 4 pi epsilon naught q divided by x square multiplied by dx, where negative sign indicates that displacement is opposite to the direction of electric force, or displacement is against the electrostatic force. And the next one, the total work done in displacing unit positive charge from infinity to the point in an electric field, that is x is equal to infinity to x is equal to r. Then total work done we can write integrating the above equation between the limits x is equal to infinity to x is equal to r. On substituting dw by above equation, on simplifying here only x, with respect to dx is there, therefore x is the variable, remaining factors are constant. Keep outside from the integration of 1 upon x square into dx between the limits x is equal to infinity to x equal to r. Integration of 1 upon x square dx is what? Minus of 1 by x. On substituting that value, upper limit, lower limit keep as it is, minus taken is positive, and the next one, 1 by x, upper limit x equal to r, lower limit x equal to infinity, q by 4 by x not keep as it is. And the next one, in the place of x first we have to substitute the upper limit minus, then we have to substitute the lower limit. Therefore, q by 4 by epsilon naught 1 by r minus of 1 by infinity. And the next one, the next statement is what? Here 1 by r keep as it is, 1 by infinity reduces to 0. Therefore, w is equal to 1 by 4 by epsilon naught q divided by r. By the definition of electric potential, amount of work done in moving unit positive charge from infinity to the point in an electric field without acceleration is called electric potential at that point. Therefore, here we are moving 1 coulomb of charge from infinity to the point in an electric field. Therefore, the work done and electric potential both are numerically equal to each other. In the place of W, we have to substitute by V is equal to 1 by 4 by epsilon q divided by r. This is what the expression for electric potential at a point due to an isolated point charge, where q is what? Source charge, and r in the sense what? Distance at which we are calculating the electric potential, and 1 by 4 by epsilon in the sense what? The medium. Basically, epsilon naught in the sense what? Permittivity of the space. Pi is constant, 4 is constant. And the next one, instead of a positive charge, if source charge is negative, then electric potential would be negative. That is given by V is equal to 1 upon 4 pi epsilon naught minus q divided by r, where r is what? Distance at which we are calculating the electric potential due to negative charge, and the given charge, the given negative charge is what? Minus q. 1 upon 4 pi epsilon is the constant, where epsilon naught is what? The permittivity of a free space. And I will explain the same concept in Kannada because most of our students are familiar with their mother tongue. ಇಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಕನ್ಸೆಪ್ಟ್ ಹಿಂದಿನ ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸ್ ಒಳಗೆ ನಾವೇನು ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಕನ್ಸೆಪ್ಟ್ ಅನ್ನ ಡೀಲ್ ಮಾಡಿದ್ವಿ. ಇಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಇರ್ತಕ್ಕಂಥ ಕನ್ಸೆಪ್ಟ್ ಏನಂತಂದ್ರೆ ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಒಳಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಒಂದು ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಇಂದ ಎಷ್ಟು ಬರ್ತೈತೆ ಅನ್ನೋದನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದ. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನ ಹೆಂಗೆ ಡಿರೈವ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನ ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ಯಾಟಿಕಲಿ ತೋರಿಸಿದ್ದೇವೆ. ಇಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಅನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೇವೆ. ಆ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಅನ್ನು ಕ್ಯೂ ಅಂತ ಕರೀತೀವಿ, ಅದನ್ನು ಓ ಒಳಗೆ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದೇವೆ. ನೆಕ್ಸ್ಟ್ ಮತ್ತೊಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ 1 ಕೂಲಂಬ್ ಇದನ್ನ ಪಿ ಪಾಯಿಂಟ್ ಒಳಗೆ ಪ್ಲೇಸ್ ಮಾಡಿದೆವು. ಇವೆರಡೂ ಚಾರ್ಜಸ್ ಎಕ್ಸ್ ಡಿಸ್ಟೆನ್ಸ್ ದಿಂದ ಸೆಪರೇಟ್ ಆಗಿದಾವು. ನೆಕ್ಸ್ಟ್ ಆ ಡಿಸ್ಟೆನ್ಸ್ ಅನ್ನ ಹೆಂಗ್ ಬರೀತೀವಿ ಅಂದ್ರೆ OP is equal to x ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲಿ ಎರಡು ಚಾರ್ಜಸ್ ಲೈಕ್ ಚಾರ್ಜಸ್, ಈಗ ಪ್ಲಸ್ 1 ಕೂಲಂಬ್ ಇದು ಪ್ಲಸ್ q ಚಾರ್ಜ್, ಎರಡೂ ಕಡೆ ಬರತಕ್ಕಂತ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಮತ್ತೆ ರಿಪಲ್ಷನ್ ಅನ್ನ ನಾವು ಹೆಂಗ್ ಹೇಳ್ತೇವೆ ಅಂತಂದ್ರೆ F is equal to 1 by 4 pi epsilon q upon x square ಅಂತ ಹೇಳ್ತೇವೆ. ಅಂದ್ರೆ ಇದನ್ನ ಬಿಟ್ಟು ಹೇಳಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಎರಡು ಲೈಕ್ ಚಾರ್ಜಸ್ ಇರೋದ್ರಿಂದ ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಎರಡೂ ಕಡೆ ವೇಸ್ಟ್ ಆಗ್ತೈತಿ. ಅಕಾರ್ಡಿಂಗ್ ಟು ಕೂಲಾಂಬ್ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಇಂದ ಹೆಂಗ್ ಬರೀತೀವಿ ಅಂತಂದ್ರೆ F is equal to 1 by 4 pi epsilon naught mod of q multiplied by mod of 1 divided by x square. ಇಲ್ಲಿ mod of q ಅನ್ನ q ಅಷ್ಟು ಬರೀತೀವಿ, mod of 1 ಅಂದ್ರೆ 1 q into 1 Q1 ಅಂದ್ರೆ Q ಅದಕ್ಕೆ ನ್ಯೂಮರೇಟರ್ ಆಗಿ Q ಅಂತ ಬರೀತೀವಿ. ಎರಡು ಚಾರ್ಜ್ ನಡುವೆ ಇರತಕ್ಕಂತ ಡಿಸ್ಟೆನ್ಸ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರೀತೀವಿ, x ಸ್ಕ್ವೇರ್ ಅಂತ ಬರೀತೀವಿ. ಇದರ ಡೈರೆಕ್ಷನ್ ಅಲಾಂಗ್ ಹೋಗಿ ಅಂತ ಬರೀತೀವಿ. ಯಾಕ ಇಲ್ಲಿ 1 ಕೂಲಂಬ್ ಅಂತಂದ್ರೆ ಟೆಸ್ಟ್ ಚಾರ್ಜ್, ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅಂತ ಬರೀತೀವಿ. ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಬೇಸಿಕಲಿ ಏನ್ ಹೇಳ್ತೈತೆ ಅಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟೈತೆ ಅನ್ನೋದನ್ನ ಟೆಸ್ಟ್ ಮಾಡೋ ಸಲುವಾಗಿ ನಾವು ಲೀಸ್ಟ್ ಚಾರ್ಜ್ ಅನ್ನು ತಗೊಂಡು ಅದಕ್ಕೆ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಟೆಸ್ಟ್ ಚಾರ್ಜ್ ಅಂತ ಕರೀತೀವಿ. ಈ Q ಅಂದ್ರೆ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಏನ್ ಮಾಡ್ತದೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನು ತನ್ನ ಸುತ್ತಮುತ್ತ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತದೆ. ಅದಕ್ಕಾಗಿ ಇಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಏನ್ ಬರೀತದೆ ಅಲಾಂಗ್ ಹೋಗಿ ಬರೀತೀವಿ. ಯಾಕ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ಡ್ ಬೈ 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಡ್ಯೂ ಟು Q is nothing but Coulomb force between Q and 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಅಂತ ಬರೀತೀವಿ. ಅದಕ್ಕೆ ಡೈರೆಕ್ಷನ್ ಏನ್ ಬರೀತೀವಿ ಅಲಾಂಗ್ ಹೋಗಿ ಅಂತ ಬರೀತೀವಿ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಅನ್ನ P ಪಾಯಿಂಟ್ ಇಂದ A ಪಾಯಿಂಟ್ ಗೆ ಡಿಸ್ಪ್ಲೇಸ್ ಮಾಡಿದಾಗ ನೆಕ್ಸ್ಟ್ ವರ್ಕ್ ಡನ್ ಬೇಕು. ಆ ವರ್ಕ್ ಡನ್ ಅನ್ನು ಹೆಂಗ್ ಬರೀತೀವಿ ಅಂತಂದ್ರೆ dW ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ಡಾಟ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ವೆಕ್ಟರ್ ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲಿ ಫೋರ್ಸ್ ಆರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಈ ಪ್ರಾಡಕ್ಟ್ ಏನ್ ಹೇಳ್ತದೆ ಸ್ಕೇಲಾರ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟು ವೆಕ್ಟರ್ಸ್ ಅಂತ ಹೇಳ್ತದೆ. ಇದನ್ನ ನಾವು ಹೆಂಗೂ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ವೆಕ್ಟರ್ ಕೊಸೈನ್ ಆಫ್ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ಫೋರ್ಸ್ ವೆಕ್ಟರ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ವೆಕ್ಟರ್. ಇಲ್ಲಿ ನೋಡ್ರಿ ನಾವು P ಪಾಯಿಂಟ್ ಇಂದ A ಪಾಯಿಂಟ್ ಗೆ 1 ಕೂಲಂಬ್ ಚಾರ್ಜ್ ಅನ್ನು ಡಿಸ್ಪ್ಲೇಸ್ ಮಾಡಕತ್ತೀವಿ. ಆದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಡೈರೆಕ್ಷನ್ ಅವಾಗ OP ಇದೆ. ನೆಕ್ಸ್ಟ್ ಫೋರ್ಸ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಒಂದಕ್ಕೊಂದು ತಪ್ಪಿರೋದ್ರಿಂದ ಎರಡು ಆಂಟಿ ಪ್ಯಾರಲಲ್ ಇರೋದ್ರಿಂದ ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ದಮ್ ಏನು ಬರೀತೀವಿ 180 ಡಿಗ್ರಿ ಅಂತ ಬರೀತೀವಿ. cos ಆಫ್ 180 ಅಂತಂದ್ರೆ ಎಷ್ಟು -1. ಇದರ ವ್ಯಾಲ್ಯೂನ ಮ್ಯಾನ್ಯುಯಲ್ ಈಕ್ವೇಷನ್ ಒಳಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಈಕ್ವೇಷನ್ ಈ ರೀತಿ ವಿತ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಿದೆ. ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಏನಂದ್ರೆ ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಏನು ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೈತೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಮತ್ತು ಫೋರ್ಸ್ ಒಂದಕ್ಕೊಂದು ತಪ್ಪಿರೋದ್ರಿಂದ ಅವು ಅಗೇನ್ಸ್ಟ್ ಮಾಡೋದನ್ನ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಇದಾದ ಕೂಡಲೇ ನೆಕ್ಸ್ಟ್ ಏನ ಇದ 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಇನ್ಫಿನಿಟಿ ದಿಂದ ಈ A ಪಾಯಿಂಟ್ ಗೆ ತರಬೇಕಾದ್ರೆ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಎಷ್ಟು ಬೇಕು ಆ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಅನ್ನು ಹೆಂಗ್ ಬರೀತೀವಿ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ dW from x equal to infinity to x equal to r ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲಿ ನೋಡ್ರಿ dW ವ್ಯಾಲ್ಯೂ ಮ್ಯಾನ್ಯುಯಲ್ ಈಕ್ವೇಷನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ರಿ. ಇಲ್ಲಿ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು dx ಇದೆ ಇಂಟಿಗ್ರೇಷನ್. ಅದಕ್ಕಾಗಿ 1/4πε0 q ನೆಗೆಟಿವ್ ಸೈನ್ ಎಲ್ಲ ಕಾನ್ಸ್ಟಂಟ್ ಹೊರಗಿಡ್ರಿ. ಉಳಿದಂತ ವೇರಿಯಬಲ್ ಅನ್ನ ಇಂಟಿಗ್ರೇಷನ್ ಫ್ಯಾಕ್ಟರ್ ದಾಗ ಬರೀರಿ. ಇದನ್ನ ಬರೀತೀವಿ -q ಡಿವೈಡೆಡ್ ಬೈ 4πε0 ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ 1/x² dx integration between the limits x equal to infinity to x equal to r ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲಿ 1/x² dx ಇಂಟಿಗ್ರೇಷನ್ ಹೆಂಗ್ ಬರೀತೀವಿ ಅಕಾರ್ಡಿಂಗ್ ಟು ಈ ರೂಲ್ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ x raised to n dx ಅಂತ ಬರೀತೀವಿ x raised to n plus 1 divided by n plus 1. ಇದರ 1/x² ಇದೆ x² ಮ್ಯಾಲ ಆದ್ರೆ x raised to -2 dx ಇಂಟಿಗ್ರೇಷನ್ ಹೆಂಗ್ ಬರೀತೀವಿ x raised to -2 plus 1 divided by -2 plus 1. ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ x raised to -1 divided by -1 is equal to -1/x. ಅದಕ್ಕೆ ಡೈರೆಕ್ಟ್ಲಿ ಹೆಂಗ್ ಬರೀತೀವಿ ಅಂತಂದ್ರೆ ಹೆಂಗ್ ಬರೀತೀವಿ 1/x² dx ಇಂಟಿಗ್ರೇಷನ್ ಅನ್ನು -1/x ಅಂತ ಬರೀತೀವಿ. ಈ ಫ್ಯಾಕ್ಟರ್ ಬದಲಾಗಿ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀತೀವಿ -1/x x equal to r x equal to infinity ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಲೋವರ್ ಲಿಮಿಟ್ ಅಂತ ಹೇಳಿ. ಇದಾದ ನಂತರ ನೆಕ್ಸ್ಟ್ ಏನ ಇದು ನೆಗೆಟಿವ್ ಬಿಕಮ್ಸ್ ಪಾಸಿಟಿವ್. ಇನ್ ದ ಪ್ಲೇಸ್ ಆಫ್ x ಮೊದಲು ಏನ್ ಮಾಡಬೇಕು ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಅನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು ಮೈನಸ್ ಇನ್ ದ ಪ್ಲೇಸ್ ಆಫ್ x ಏನ್ ಮಾಡಬೇಕು ಲೋವರ್ ಲಿಮಿಟ್ ಅನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. 1 divided by infinity ಅಂತಂದ್ರೆ 0. ಅವಾಗ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ರಿ 1/4πε0 q divided by r. ಇದಕ್ಕೆ ಏನು ಬರೀತೀವಿ ನಾವು ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಇನ್ ಮೂವಿಂಗ್ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಫ್ರಮ್ ಇನ್ಫಿನಿಟಿ ಟು ದ ಪಾಯಿಂಟ್ ಇನ್ ಆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಕರೀತೀವಿ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಡೆಫಿನಿಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಏನ್ ಹೇಳಿದೆ ಒಂದು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನ ಇನ್ಫಿನಿಟಿ ದಿಂದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಗೆ ತರಬೇಕಾದ್ರೆ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಬೇಕು ಆ ವರ್ಕ್ ಡನ್ ಗೆ ನಾವು ಕರೀತೀವಿ ಆ ಪಾಯಿಂಟ್ ದಾಗ ಇರತಕ್ಕಂತ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂತ ಕರೀತೀವಿ. ಇಲ್ಲಿಯೂ ಅದನ್ನ ಮಾಡಾಕತ್ತೇವೆ ಇನ್ಫಿನಿಟಿ ದಿಂದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ದಾಗ ಇರತಕ್ಕಂತ A ಪಾಯಿಂಟ್ ಗೆ ನಾವು 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜ್ ಅನ್ನು ತರಕತ್ತೇವೆ. ಅದಕ್ಕಾಗಿ ಇಲ್ಲಿ ವರ್ಕ್ ಡನ್ ಮತ್ತು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎರಡೂ ಸೇಮ್ ಇರೋದ್ರಿಂದ W ಬದಲಾಗಿ V ಅಂತ ಬರೀತೀವಿ. V is equal to 1/4πε0 q divided by r ಅಂತ ಬರೀತೀವಿ. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನ್ ಹೇಳ್ತದೆ ಇಲ್ಲಿ ಹೇಳ್ತೀವಿ ಚಾರ್ಜ್ q ದಿಂದ r ಡಿಸ್ಟೆನ್ಸ್ ನಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಐತಿ ಅನ್ನೋದನ್ನ ಡೈರೆಕ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಹೆಂಗ್ ಬರೀತೀವಿ 1/4πε0 q divided by r ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲಿ 4 ಅಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ pi ಅಂದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ 3.1414. ನೆಕ್ಸ್ಟ್ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಅಂತಂದ್ರೆ ಏನ ಫ್ರೀ ಸ್ಪೇಸ್ ಪರ್ಮಿಟಿವಿಟಿ ಅಂತ ಕರೀತೀವಿ. ಇದರ ವ್ಯಾಲ್ಯೂ 8.854 into 10⁻⁻12 farad per meter ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲಿ q ಚಾರ್ಜ್ ಪಾಸಿಟಿವ್ ಐತಿ r ಡಿಸ್ಟೆನ್ಸ್ ನಲ್ಲಿ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಐತಿ ಅನ್ನೋದನ್ನ ಹೆಂಗ್ ಬರೀತೀವಿ v is equal to 1/4πε0 q divided by r ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲಿ ಚಾರ್ಜ್ q ಒಂದು ವೇಳೆ ನೆಗೆಟಿವ್ ಇತ್ತಂತಂದ್ರೆ ಅವಾಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಸಹಿತ ನೆಗೆಟಿವ್ ಬರ್ತೈತಿ. ಆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನು ಹೆಂಗ್ ಬರೀತೀವಿ ಅಂತಂದ್ರೆ v is equal to 1/4πε0 minus q divided by r ಅಂತ ಬರೀತೀವಿ. ಇಲ್ಲಿ ಮೀಡಿಯಂ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಅಂತಂದ್ರೆ ಏನ ಇಲ್ಲಿ ಚಾರ್ಜಸ್ 1 ಕೂಲಂಬ್ ಮತ್ತು q ಎರಡು ಎಲ್ಲಿದಾವು ಏರ್ ಮೀಡಿಯಂ ವ್ಯಾಕ್ಯೂಮ್ ಮೀಡಿಯಂ ಅಥವಾ ಫ್ರೀ ಸ್ಪೇಸ್ ಮೀಡಿಯಂ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ತೇವೆ. ಈ ಕಾನ್ಸೆಪ್ಟ್ ನ ನಾವು ಏನ್ ಬರೀತೀವಿ ಅಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ at a point due to an isolated point charge. ಇದರ ಉಳಿದಿದ್ದ ಕನ್ಸೆಪ್ಟ್ ಅನ್ನ ಮುಂದಿನ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಒಳಗೆ ಹೇಳ್ತಾನೋ. ಥ್ಯಾಂಕ್ ಯು.